Both natural gas and oil are two non-renewable energy sources. As Janet Larson from earthpolicy.org in March 2013 stated, U.S. Gasoline consumption in 2013 rose to 134 billion gallons per year. As we continue to use these dwindling resources, innovation and creative thinking have to take place. You should listen to me because our lives depend upon fossil fuels and non-renewable energy sources. As explained by Andrew A. Rosenberg in Issues in Science and Technology in fall 2014, U.S. production of natural gas from shale has increased tenfold, whereas production of tight oil from shale has increased 16-fold. So innovations like these are allowing us to continue to use these reserves that were before thought to be quickly depleted. In this speech, I will explain the process. I will discuss hydraulic fracturing. First, we will discuss the origins of hydraulic fracturing and the catalysts that made it come about. Second, we will discuss the process of hydraulic fracturing. And finally, we will discuss some of the positive and negative aspects of hydraulic fracturing. So, as we begin our discussion, hydraulic fracturing came about in the 1980s. In the past, vertical drilling was the only way to create a well in order to tap into reserves that were deep underground. These wells or reserves were held under great pressure due to the water and ground above it. This causes, once a well is drilled, the pressure is released, allowing the fluid and natural gas to flow up to the top where it can be harvested. As explained by Thomas W. Merrill, environmental lawyer, in 4 Questions About Fracking in 2013, traditional oil production and natural gas production involves a vertical well from the surface down into the reservoir. Once it's tapped into, the pressure is released, allowing natural resources to flow freely. So due to the pressure of all the weight of the sand, water, and ground above it, it's held under great pressure. So once the well is tapped into it, the pressure is released. So this process is only effective with permeable rock. So for non-permeable rock, this process is not effective. So as you can imagine, all the easily welled options were quickly depleted. So the larger gas and oil companies were able to purchase more lucrative and bigger oil fields where they can continue their business. Whereas the smaller gas and oil companies weren't able to do so they had to make ends meet where they were. So George P. Mitchell is actually credited for combining hydraulic fracturing and horizontal drilling together in order to tap into tight oil. Tight oil is oil and natural gas that is in non-permeable rock, and it was a well-known fact that these formations have large amounts of natural resources. So in Texas, in the Barnett Shale fields, George P. Mitchell was able to find the right set of circumstances to combine these two together to make this process work. So now this process is actually one of the most effective and widely used processes in order to harvest both natural gas and oil. So as we've discussed the origins of hydraulic fracturing, now we can discuss some of the processes of hydraulic fracturing. All right, so both hydraulic fracturing and conventional well drilling of a vertical well have similar processes. Both start off with one vertical well that starts. You can move that up a little bit. At this point, there's a concrete casting at the top of the well to ensure that the cross-contamination into the water table is not allowed. As described by Thomas W. Merrill as previously qualified, as the name suggests, horizontal drilling starts off vertical, and then at some point the drill bit turns 90 degrees in order to follow the horizontal seam of shale or coal. If you could move the picture up a little bit. Down here. So the seam of shale or coal holds a lot of natural gas, and they form in these very thin horizontal seams. So this component of hydraulic fracturing is very important because it lines up the piping right into the seam. So after this portion is done, you can switch the image. The next component of hydraulic fracturing is introduced. So the well is drawn down past the water table, down into the shale or coal formation, and the fracking fluid or slick water is injected under high pressures down to this well to create fissures or cracks within this non-permeable rock. As described by Rachel Ehrenberg, political or scientific journalist in The Fact Behind the Frack in 2014, Millions of gallons of fracking fluid, a mixture of sand, water, and chemicals, is injected under high pressures down into the well, which causes fissures, releasing the natural resources where they can be harvested at the surface. So this process is very important because without this high pressure water, the cracks wouldn't be able to be forced open and the natural resources wouldn't be able to be harvested. So some of the chemicals that are involved in this are antibacterials that kill the bacteria within the actual well, so there's no damages that would release the fluid into the groundwater, into the water table. Sand is also used in this mixture to hold open these cracks within the fissure so that the natural gas and oil can flow out of it. And yeah, so those are all very important components of this process in order to ensure that it's harvesting everything that we can get out of these. So that is some of the processes of hydraulic fracturing, and now we can move on to some of the positive and negative aspects of hydraulic fracturing. So, as I described before, there are many different processes to hydraulic fracturing, and in each one of these steps, there are different risk factors that are presented. So if these steps aren't done correctly, there are many different things that can go wrong. So those two images before were images of the proper uses of hydraulic fracturing, whereas this image here is explaining some of the things that could go wrong. So two of the major concerns with hydraulic fracturing are the air and water pollution around the site. So as this image depicts, there is there is a chance that in the for the water table, once these fissures are created within the shell, some of these cracks might be long enough to reach the water table above it, which would allow the transfer of these chemicals into our drinking water. As the picture depicts, that drinking water goes into somebody's house. So that's one of the major concerns with the water around the site. Also, there's a chance that methane will leak into this water and end up in our houses. There are some instances that people's water in their kitchen was flammable due to the amount of methane that came into their house, which is a very big concern for environmentalists and everyone alike. Also, for water, the fracking fluid is highly toxic, as you guys heard before. So it's important that these fracking fluids are stored correctly. If you could switch the... So the fracking fluid is often stored in these large plastic containers, which also are susceptible to leakage that will go right back into the groundwater that can contaminate our drinking water. Also, if they're not stored in these large recovery tanks, they'll dig out a giant pit, line it with plastic, and store the water in there. Though this seems like it's pretty unreasonable, the plastic lining could crack, which would allow the fracking fluid to go back into the groundwater and into our homes. And if there's a chance of rain, this runoff will lead back into the streams and rivers in the local community, which also goes back to the groundwater. So that's some of the concerns with water, whereas for air, there's also a chance of methane leakage into the air, which is another detrimental cause that is so not good for you. Also, the vehicles and machinery used on the job site, whereas like trucks and the well drilling and all that stuff, they run off diesel, which emits a lot of smog, which is also not good for the environment and the surrounding communities. Another concern with hydraulic fracturing is earthquakes. Though more studies have to be done, there is seismic activity once the high pressure fluid is injected into the ground, though it's barely negative 0.2 magnification or something like that. So those are some of the negative aspects of hydraulic fracturing. We'll touch base on some of the positive aspects. Due to this process alone, 1.7 million jobs are created, which is great for our local economy. And because of all these jobs and all the increase of oil production and natural gas production, we are able to not rely on foreign oil, which is great for our economy as well. So due to this process, we're able to become more self-sufficient instead of relying on other countries for our resources. So in my speech, I have discovered hydraulic fracture. I have elaborated on hydraulic fracturing. First, we discussed the origins of hydraulic fracturing. Then we discussed the process of hydraulic fracturing. And finally, we had discussed some of the positive and negative aspects of hydraulic fracturing. So as college students, it's important that we are aware of all these processes because fossil fuels will be used for the rest of our lifetime. They're dwindling resources. It's important that we are aware of the process that is used to harvest these resources and whether or not we should continue to use these resources. So I hope that you guys have a better understanding of hydraulic fracturing.